All right, so we're up to number three. Number three and number four, you'll notice, have two variables. So that makes it a little more complicated, but it's still doable. So let's take a look at number three. Um, Again, I'm going to look at the right hand side first. X cubed minus y cubed. Those are not like terms. There is no um, combining of like terms. There's no simplifying I can do. So the right hand side is actually already simplified. So I only need to simplify the left hand side. And if I end up with x cubed minus y cubed, then it's an identity. If I end up with anything else, then it's not an identity. So to simplify the left hand side, I am going to once again box method. So x plus y. Again, just because there's two variables is not going to change the way that I solve this problem. So let's look at row one. So x times x squared is going to be x cubed. Okay. The second one here is going to be x times negative xy. So this is a positive times a negative, so I know the answer is going to be negative. And then x times xy is going to be x squared y. So the final answer for that section is negative x squared y. Notice when I wrote out the answer, okay, and this is just a practice that I use, when there are multiple variables, I simply use, I always put the variables in alphabetical order. Negative x squared y. X comes before y in the alphabet. This last one in the row one is going to be x times y squared. So again, if I put that in alphabetical order, that's going to be x y squared. Okay. So row two, this is going to be x squared times y. So x squared times y. Okay. This one is going to be negative xy times y. So again, it's a positive times a negative, so that's going to be negative. Xy times y is going to be xy squared. And then this last one is going to be y squared times y, which is y cubed. Okay, so again, when I have multiple variables, write it out, multiply it like you normally do, but write out the answer in alphabetical order. All right, so let's write this out. So this will be x cubed. Okay. And then I have this diagonal here is going to be x squared y and negative x squared y. That, like before, that's going to cancel. And the same thing is going to happen in the next diagonal. Negative xy squared and positive xy squared. Those are also going to cancel. So I'm going to be left with x cubed plus y cubed. And if I compare that to the right-hand side, okay, x cubed plus y cubed and x cubed minus y cubed are not equivalent expressions. The plus and the minus make a difference. So is number three an identity? The answer is no, it is not.